Hello guys, welcome to another section of our studies concerning linear equation. Today we are going to study specifically on the graphical solution to linear inequalities in two variables, where we will be basing on the shading region on the Cartesian plane. What are linear inequalities in two variables? And before you can understand this particular section of our studies, I will plead with you to go back and watch our previous videos on linear equations. We've done a lot before getting to this particular point. So, from our previous studies or videos, we learned that linear inequalities are expression in a linear form that uses the symbols less than or equal to, greater than or equal to. So this time we are going to deal with inequalities with two variables of the form ax plus by less than c, or y greater than or equal to ms plus b. This is the general representation of them. It means that we can get to the point that we have ax plus by less than or equal to c, y greater than ms plus b. So as far as there is two variables, which is x and y, then with the use of the inequality sign, greater than or equal to, less than or equal to 2, the expression becomes and a linear inequality in two variables. And how do we find the solution of a linear inequality in two variables? Solution is a region on the coordinate plane. So the region on the coordinate plane determines the solution for that particular inequality. Good. Then let's look at the strategy for the graphing. If we want to solve for the linear inequality of a particular line, we can use the graphing aspect. But what strategy are we going to use for the graphing? The first point is we should rewrite the expression which was initially, which is now in the inequality form, to be in the form y equal to mx plus b. So here we are going to get an expression, maybe we have an expression of the form y greater than ms plus b. Since we want to sketch this particular graph, then we are going to find or rewrite, change the inequality sign to be in the form of equal to. So the expression now tends to be y equal to mx plus b. Now, when we have y greater than ms plus b, we shade above the line. That means that we are not going to use a solid line, but we are going to use dashed line. The dashed line indicates that the borderline is not part of the region that will give us our solution. So this one indicates the borderline. That is the reason why we've removed the inequality sign and replace it with equal to sign. Good. So if we have y less than ms plus b, it means that our solution for the region is below this particular borderline. Yes, it's below the line. So here too, we are going to use dashed line. But when we end up getting or using greater than or equal to for this particular function as an example, then it means we are going to shade above the line, but this time we are not going to use dashed line, but rather solid line, meaning the borderline is also part of the solution. Then the same applies to this one. We are going to shade below the line, that this time is going to be solid line, meaning the borderline is part of the solution. Let's look at the key steps to follow. Let's look at the key steps to follow. Now, number one, we should find the intercept on the x and y axis. So we've learned this thing before, how to plot a linear graph. So we find the intercept on the x and the y axis. Then two, we prepare a table of values in order to get the point to plot the graph. And the graph, since it is linear, the graph will be in the form of a straight line. Then the three, we draw boundary line. We draw boundary line. So the boundary line is the line that we've sketched. Good. Then the boundary line might be part of the solution or might not be part of the solution. So this time, when the inequality is less than, what it means is that we are going to use dashed line. If it is greater than, we are going to use dashed line. If it is less than or equal to, we are going to use solid lines. And if it is greater than or equal to, we are going to use solid line. So the four aspects of this particular step is to shade based on the inequality symbol, the region of solution. We are going to shade it. Now let's consider this particular example. That is our example one for this particular studies. We have 2x minus 3y less than 4. First of all, before we can find a solution for this particular inequality, the first thing that we need to do from the key step is to make y is to turn the inequality sign here to be equal to and make y the subject. So that is what I've done here. So 2x minus 3y equal to 4. Then at the end of it, I'll make y the subject, and making y the subject will allow us to arrive at a point where y will be equal to 2 over 3x minus 4 on 3, so that the boundary of this solution can be drawn. So after getting the boundary, then it means that this y, after making it the subject, was to be y uh, greater than 2 on 3x minus 4 on 3. Should have write that one here. So this y will be greater than y because we are going to divide both sides with a negative number, which is negative 3. So that will change this inequality sign, which is less than, to become what? Greater than. So that is the reason why it is advisable to always make sure that y becomes the subject of the relation. So the moment we have a greater than sign, it means that we are going to shade above the graph, not below. So if you only focus on this one without carefully analyzing this particular situation in the form of making y the subject, you get to understand that, or maybe uh, try to do something like shading the down here, because we are dealing with less than sign as the inequality sign for this particular relation. That is, the answer will be wrong. The best thing to do is to make y the subject. After making y the subject, you are going to have a perfect inequality in the form of the ones that we've studied from our previous slide. So here we are going to shade above the line. Why? Because y will be greater than 2 over 3x minus 4 on 3. Good. We got that by making y the subject. So that is it. You can also do that by testing, using 0, to test to see which portion satisfies the condition. Good. Okay, let's also consider example 2 here. We have 2x minus 3y less than 6. The best thing to do is to turn the inequality sign to be equal to. After that, you make y the subject. So per this relation, when you make y the subject, the inequality sign, which is less than, will now tends to be greater than in this particular form. It means that after drawing our borderline, we are going to shade above the line, as you see here. Good. So you can also do the testing by using the point 0, to and substitute the point at this side. So when you do that, you get 0, and 0 is less than 6. It means that the point above the line satisfy the inequality. So example 2 is very, very, very clear and understandable. So thank you. Let's move to the example 3. Example 3. For example 3, we have a graph of y plus 2x greater than or equal to 3. As we said, the best thing to do is to make y the subject in this particular relation. So y is greater than or equal to minus 2x plus 3. So we have the inequality sign greater than or equal to. So we will plot the graph of y equal to. We are going to remove the greater than or equal to and use the equation sign, the equal to sign, and that will help us to draw our border line. So how do we draw the border line? We find the intercept on both axes, both the x-axis and the y-axis. And on the x-axis, you are going to realize that y part to be 0. Then we find the value for the x. And on the y-axis, you are going to realize that x part to be 0. Then you find the value for y. Then these points are there. You can also draw a table of points. Then use the table of points to sketch your borderline graph. So this is the line, and this time the line is not a dashed line but rather a solid line. Why? Because the inequality sign here is with equal sign, that we are having greater than or equal to. So we shade the region, so the region will be above the line. Why? Because after rearranging this one to make y the subject, we realize that y is greater than or equal to minus 2x plus 3. So the region will be above the line. So you can also test. When you do your testing, use the origin, as I said, 0, 0. Put the 0 here and put the 0 here. The answer that you are going to get will be 0. And 0 will never be greater than or equal to 3. So it means that the down or the region below the graph fails the test. But if the region below the graph fails the test, then the region above the graph passed the test. Good. Then you shade that particular region or space as your solution. So shading, remember, use text point 00 if not on the line. That helps a lot. You realize that I was using the text point 00. Then the dash is not, it means that the line is not included when you use the dash line. Solid line means that the line is included. So you need to be very sensitive to the use of this particular line. So if you are using dash line, know the reason why you are using it. If you are using solid line, know the reason why you are using it, because that counts a lot. It means a lot. Good. So let's see the real life connection and a class activity for you to practice your hands on. So we can use this one in budgeting, and we can use it in constraints and design. There are a lot of lessons coming and you understand them very much. They are more useful a lot, and you get to know the importance of studying linear inequality. They are very interesting and they help to solve a lot of problems, especially when it comes to optimization. So let's see this. We have 2x plus y less than or equal to 100. This one is about time or cost constraint. So you can try your hands on this one to know the region that satisfies this particular condition. So there is an activity for you. I'll urge you to try your hands on them, then give us a comment on this particular channel, the comment section, or you can send it to my email or my WhatsApp number for us to go through your work for you. Good. So let's see the summary. The summary about this study was to convert the inequality sign to a line to draw that boundary line. The way we draw the boundary line is to identify the intercept on both the x and y axis. We are supposed to use the dash or the solid line, shade the region that satisfies the inequality. Thank you for watching. Don't forget to subscribe. God bless you.